This video is for lesson 3.3 from chapter 3, solving equations using addition or subtraction. Our essential question, how can we solve addition and subtraction equations? Well, one vocabulary term that I would like to review with you before we get started is equivalent equations. So if you can remember what the word equivalent means, you can look inside of it, almost see the word equal. Right? Equivalent equations are equal equations. They have the same solution. Let's fill that in. Have the same solution. So equations that are equal, they have the same solution. All right, and remember, when we're talking about a solution, we're talking about an answer. Right? So equivalent equations have the same answer because they are the same equation. They're equivalent. They might not look exactly the same, but when you solve them out, they are equivalent. So they're the same on both sides of that equal sign. All right, we have a key point here. Remember that addition and subtraction are inverse operations, meaning opposite operations. They undo each other. Therefore, if I need to solve an addition equation, I'm going to solve it by using the inverse operation, which is subtraction. And if I'm solving a subtraction equation, I'm going to solve it by using its inverse operation, which would be addition. All right, so our key ideas, we have the addition property of equality. Adding the same number to each side of an equation produces an equivalent equation. If A is equal to B, if they are the same, then A plus C is equal to B plus C. So if we add C to both sides, you're still going to have the same numbers that you started with because A and B were the same. Similarly, the subtraction property of equality. If you subtract the same number from each side of an equation, that will also produce an equivalent equation. If A is equal to B, if they are the same, and you subtract C from A and you subtract C from B, then you still have an equivalent equation. All right, they're still the same. So just as a quick reminder, see if you can answer those two questions at the bottom. What operation is used to solve an addition equation? And what operation is used to solve a subtraction equation? I'll give you a couple seconds to fill those in. All right, solving an addition equation, what's the inverse operation of addition? Subtraction. So we use subtraction to solve. And what operation is used to solve a subtraction equation? Well, what's the inverse operation of subtraction? Addition. Right, so we use our inverse operations to solve equations. So let's look at an example of this without just letters, and it might make a little bit more sense to you. So in example 1, we're going to solve for x, which means we have to undo that subtraction. We have to use its inverse operation. What's the inverse operation of subtraction? Addition. How am I going to get x by itself? In order to get x by itself, I need to remove that minus 5. And whatever I do to one side of the equation, I need to do to the other side as well to keep it even. Just like how they subtracted c from one side, they also had to subtract c from the other side when we were looking at the key idea. So how am I going to get rid of this minus 5? The inverse operation would be to add 5. So think about it. What is negative 5 plus 5? 0. It's now gone. We can cross it out. But since I added 5 on this side and I drew the line to remind you that whatever you do to one side, you must do to the other, I must add 5 on the other side as well. Draw that line. It's going to help you to remember what you do to one side, you must do to the other. So many people forget. They get rid of the 5 and they just bring down that x, and it makes no sense. We got to make sure that we do the inverse operation on both sides. So now we can see that I only have x left over here, so I have x by itself. And x is going to equal negative 1 plus 5. What's negative 1 plus 5? Negative 1 plus 5. My signs are different. I find the difference. 5 minus 1 is 4. And I take the sign of the higher absolute value, which would be the 5, so my answer is a positive 4. So x equals 4. Now, I always want to go back and check my solution. So I'm going to substitute 4 in for the x. So 4 minus 5 equals negative 1. We have to see if that is a true statement. 4 minus 5. Subtracting integers, we do keep change opposite. Keep change opposite. I now am finding the difference because I have a positive and a negative. My signs are different. I find the difference. which would be 1, taking the sign of the higher absolute value, which would be the 5, so it's a negative 1. Does negative 1 equal negative 1? Is that an equivalent equation? Yes, it is, so it checks out. If you look at B in example 1, z plus 3 over 2 equals 1/2. I want to get z all by itself, which means I need to remove that plus 3 over 2. What's the opposite of adding 3 over 2? Subtracting it. Inverse operations. Inverse operations always take us back to 0. Since I did it on that side, I must do the same thing over here. I now have z by itself on this side, and it's going to equal 1/2 minus 3 over 2, which ends up being negative 1. I'm now going to substitute that negative 1 back into the equation to check it. So z becomes negative 1. Negative 1 plus 3 over 2 equals 1/2. Negative 1 plus 3 over 2, I have different signs, finding the difference here. When I find the difference, I then will take the sign of the higher absolute value, which is going to be positive, because 3 over 2 is actually 1/2. So this gives me a positive 1/2 on this side, and a positive 1/2 on that side. They match. They are equivalent expressions. So just going back over, I saw a minus sign. How do I get rid of it? Inverse operation was to add. Here I have an addition sign. How did I get rid of it? I used the inverse operation, which was to subtract. Right? So we're using inverse operations to solve, to get the variable by itself. So pause your video, see if you can do these first 3 problems. I suggest that you go back in and check it, just like I did here. All right, substitute your value in, check your problem, and then move to the next one. Press play when you're ready so you can check your answers. So in number 1, we're trying to get rid of a minus 5. The opposite of minus 5 would be to plus 5. And we're going to do that to both sides of the equation. Here I have my inverse operations. They cancel out. Negative 5 plus 5 is 0, leaving me with just p. And negative 2 plus 5, my signs are different. I find the difference and take the sign of the higher absolute value, which would be a positive 3. I'm going to go back and check it. 3 minus 5 equals negative 2. This is my check statement. And since I am subtracting integers, I do keep, change, opposite. I now have different signs. I find the difference, which is 2. Sign of the higher absolute value is negative. Negative 2 equals negative 2 is a true statement, therefore it is correct. In number 2, I'm trying to get w alone. I have a plus 13 and 2/10. The inverse would be to minus 13 and 2/10, and we're going to do it from both sides. Inverse operations canceling out, leaving me with w. 10 and 4/10 minus 13 and 2/10 leaves me with a negative 2 and 8/10. I'm then going to substitute negative 2 and 8/10, back in for w. Plus 13 and 2/10 should equal 10 and 4/10. This is your check. Negative 2 and 8/10 plus 13 and 2/10. They have different signs, so you're finding the difference. You're actually subtracting them, taking the sign of that higher absolute value, which is that positive 13 and 2/10. Leaves me with positive 10 and 4/10, which is what I have on the other side. So it checks out and we're good. In number 3, x minus 5/6 equals negative 1/6. I want to get rid of a minus 5/6. Inverse would be to add 5/6 to both sides of the equation. Inverse operations cancel out, leaving me with my variable. A negative 1/6 plus 5/6. You're actually subtracting because your signs are different and taking the higher absolute value, which would be positive, and it's going to be positive 2/3 for that one. When we check it, we replace the x with that positive 2/3. Sorry, not plus. Minus 5/6 should equal negative 1/6 if we did it correctly. So again, I'm subtracting integers. I should be saying to myself, keep, change, opposite. So I'm really subtracting the 2, taking the sign of the higher absolute value, which would be negative 1/6. So I now have the same thing on both sides. I have an equivalent equation. Therefore, we know that we did it correctly. In the second part of this lesson, we're going to write some equations. So in example 2, it says a company has a profit of $750 this week. So they made $750 this week. This profit is 900 more than the profit P last week. Which equation can be used to find P? So we're actually going to write the equation for this. So I want to look for some keywords. So we know we have a profit of 750. And it says this profit is in math is a key for equals. We're talking about this profit. So this profit here is really right here. 750 is 900 more than means addition, the profit P last week. And whenever we see more than or less than, that's when we flip-flop the way we read it. So I have 750 is 900 more than P. So my equation, that's in words, in actual math terms, 750, we said is equals equal. 900 more than P. So I'm going to switch the order of these two because of the more than. More than or less than switches their order. So it should say P plus 900. Now with addition, it honestly doesn't really matter, but I want you to get used to doing that when you see more than or less and flip-flopping it, because in subtraction it does matter. If you wrote it wrong in subtraction, you're not going to get the right answer. The commutative property, switching the order, doesn't work for subtraction. So technically it would work for this addition problem, but I really do want you to get used to switching the order of them when you see more than or less than. See if you can read the next one, look for some keywords, and see if you can write your own equation that matches it. Read it, write your equation, and then come back and check your work. A company has a profit of $120.50 today. This profit is $145.25 less than the profit P yesterday. Write an equation that can be used to find P. So I'm going to go through and I'm going to think about some keywords that I see. Is I see. And less than means to subtract, but we're also going to remember we want to switch the order. So when we say this profit here, we're talking about the 120.50. So if we want to think about it in terms of words, we've got $120.50 is $145.25 less than P profit yesterday, so less than P. So mathematically speaking, we've got $120.50 equals, remember these flip-flop, P minus $145.25. And if you don't have it written like that, then it is wrong. All right, the order matters here because it's subtraction and the commutative property does not work for subtraction. So you want to make sure that you start it with P minus 145.25. We don't even have to solve those because it just said to write the equation. In example 3, the line graph shows the scoring while you and your friend played a video game. Write and solve an equation to find your score after level 4. So if you look at the chart here, in green that represents you, and in blue that represents your friend's points. So after level 4, which is right here, looks like there is a difference of 33 points they're showing you. So let's put it into words first. By looking at it, we want to see who has more, who has less. Well, blue is my friend, and that's below the green. So my friend's score, I'm going to put it in words first. Your friend's score, it's definitely less. How much less is it? Well, we can see here what the difference between the two points are, is 33 points less than my score. I'm going to write then your score. Your friend's score is 33 points less than your score. So variable, what variable should we use here? Well, let's say let S be your friend's score. I'm just kind of defining what that variable stands for. And S makes sense since we're talking about scores. So my equation, my friend's score, well, let's figure out what my friend's score is. So we're looking at this point here, which we can see is at, according to my table here, level 4, she had -8 points. So my friend's score, -8, is, we know, is equals 33 points less than my score. I'm sorry, this variable should say let S be your score, not your friends. Let's get rid of your friends. Because we're writing and solving an equation to find my score, your score. So my friend's score, which is -8, is equals 33 points less than, remember, less than flip-flops it. So instead of starting with 33 points, we should be starting with the S. And less than means to subtract, -33. So that would be the equation we would use, but they actually want us to solve this now. So how would I get S alone? S has a -33 with it, so we would go back to those inverse operations. We would add 33 to both sides. These are inverse, they cancel out, leaving us with just S. And -8 plus 33 would leave me with a positive 25. Bring that S down again. So my score would be positive 25. All right, so that means that my score would be 25 points. Now look at the back of the graph. Does that make sense on your graph? Looking here, this is where your points were. Level 4, so on the x-axis over 4, and then up to, you're right in between 20 and 30, so 25 makes sense according to that table, or that chart, or that graph. All right, so see if you can come up with your own equation for the on your own problem. You have -12 points after level 1. Your score is 27 points less than your friend's score. What is your friend's score? So come up with an equation first using keywords, and then solve that equation. Pause the video, and then come back and check your answer. So for this one, you have -12 points, and your score, your -12, is 27 points less than your friend's score. So let's use S again for score. So I have -12 is 27 less than my friend's score, S, whatever that may be. So you should have did -12 equals, I see less than here, so I'm going to switch these two, S minus 27. Then to get that score, I have to get S alone, therefore I'm going to add 27 inverse operations to both sides of my equation. These inverse operations cancel out, leaving me with S, my friend's score, and -12 plus 27, find the difference because my signs are different, take the sign of the higher absolute value, leaves me with positive 15. And if we go back to the graph, here's level 1, right here. And it said your friend's score is here. So after level 1, in between 10 and 20 would be 15, so it's definitely correct.